Hey guys, I'm going to try to talk us through the lesson for 5.1 over summation notation, which some of it might be review, some of it might not. And then I'm going to try to work one example using the formula to find the exact area. Okay, so you should have a handout, the one that I have up on the screen here, the summation notation and algebra rules for finite sums. We're going to use the Greek letter S, which is a sigma. It actually looks kind of like a big E, and we use that to show sum. So if I had some terms, like two separate terms that I wanted to add together, I could write it using summation notation as the sum going from k equals from 1 to 2. Hang on. Of a sub k. And this notation would represent exactly the same thing that I have written over there, where I just have the two sums. I lost my spot. Of course. Okay, if we wanted, so this represents the sum of a sub k from k equals 1 to k equals 2. So if we had three terms to add together, a sub 1, a sub 2, and a sub 3, we could write that using summation notation as the summation of k is going from 1 to 3 this time for a sub k. So this represents the sum of a sub k from k equals 1 to 3. And in general, if we had a series here that went for a while, and so on, up to a sub n, we could write that as the summation where k is going from 1 to n of a sub k. The sum of a sub k from k equals 1 to n. So if I was actually to stretch this out down under here, the summation of k is going from 1 to n of a sub k, I would say that was equal to the first term that you would get when you would plug a 1 in, so that would be a sub 1, plus the second term you would get when you plugged a 2 in, which would be a sub 2, plus the third term you would get when you plugged in a 3, which would be a sub 3, and so on, all the way up to a sub n minus 1 to our final term would be a sub n. All right, and when we look at this, the variable k is called the index of summation. So k is our index of summation. The values of k run through the integers from 1 to n. K is always an integer. The a's are the term of the sum. In other words, a sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, a sub k is the kth term, and a sub n is the nth term. The number 1 is the lower limit of summation. The number n is the upper limit of summation. Okay? We don't necessarily always have to start at 1, though, on the bottom. All right. Hang on just a second. I got all my stuff out of order. All right. So, some examples, like this very first one that you can't see. There we go. This is read as the summation, k goes from 1 to 5 of k. So, the k is the variable that we're going to be plugging into. So, the first term would be what I get if I plug 1 in there, which is just 1. Your second term is going to be what you get when you plug in 2, which in this case is just 2. And I'm going to keep going 3, 4, 5 until I get to my upper summation, which is a 5. So then summation notation means we're going to sum up all the stuff. So we just add them all together. So 1 plus 2 plus 3 plus 4 plus 5 gives us a value of 15. All right. On the bottom, we have the summation. K goes from negative 1 to 3, and our rule here is negative 1 to the k times k. So when I plug in negative 1 on the first one, I'm going to get negative 1 to the negative 1, and then I'm going to multiply that times negative 1. So that is going to end up being what my first term would be. If we continue in order through the integers, negative 1 on my next one would be 0, so I'm going to get negative 1 to the 0 times 0. Then we're going to add to that negative 1 to the first times 1, plus negative 1 to the second times 2, and I'm supposed to go up to 3, so plus negative 1 to the third times 3. So now we got to figure out what each one of these terms are. So negative 1 to the negative 1 times negative 1 is negative 1. And I'm going to add to that negative 1 to the 0 is 1, but it's times 0, so that's going to be 0. I have negative 1 to the first, which is negative 1 times 1, which is going to give me another negative 1. So that's going to be plus another negative 1. And going on to the next term, I have negative 1 squared, which is positive 1 times 2, so that gives me plus 2. And my last term, negative 1 to the third is negative 1 times 3 is going to give me minus 3. Or plus or minus 3. All right, so if I add all these together, I have negative 1 and negative 1, which is negative 2 plus 2. Gives me 0, and then 0 minus 3 should give me a negative 3. All right. Excuse me. Okay, moving on to the next page. We've got some algebra rules for finite sums. The first one is the constant multiple rule. If you look at what we have here, we still have that a sub k term we have, but it's got a constant c multiplied to it. This can be pulled apart in that we can do c, whatever that number is, times the summation, where k is going from 1 to n of a sub k. So you can just pull that constant out, do the summation, and then multiply your answer times the c. The sum rule for summation is that you can pull them apart into two separate summations. So this could be k equals 1 to n of a sub k plus the summation k goes from 1 to n of b sub k. It works the same way for the difference rule here. So this would be the same as the summation k is going from 1 to n of a sub k minus the summation k is going from 1 to n of b sub k. All right. The constant value rule, if we have a summation of a constant, it's just going to be whatever that constant is, however many times they're telling us to go. So if my summation is going from 1 to n in this case, this is just going to be equal to c times n. Or n times c. All right, so in other words, if this went from 1 to 5, whatever this number was, I would just multiply it by 5 and I would get my summation total for that. So something like if I had the summation where k was going from 1 to 3 of the number 5, that means I would have 5 plus 5 plus 5, right, because there's nothing to substitute in, which would give me 15, or I could just do 5 times the 3. Which would also give me 15. All right. There are some formulas for the sum of a first n integers for n squares and for n cubes. And these formulas, which are already typed on your sheet here, the first one, if I have the summation k goes from 1 to n of k, if I were to add them all up, it would be the same thing as just plugging n into n times n plus 1 divided by 2. For squares, if I had k squared and I wanted to add up depending on how many terms, the n at the top here, my upper limit, I would take that number times n plus 1 times 2n plus 1 and then divide by 6. And then the sum for the number of cubes, k to the third, is n times n plus 1 divided by 2, and that quantity is squared. All right? So these three formulas are going to be used when we come up with the formula to find the area, the exact area under a curve. All right? So these next couple problems here, they're giving us some values. They've given me that the summation of k goes from 1 to n of a sub k is 2, and they've also given us that the summation k goes from 1 to n of b sub k equals negative 3. So I'm going to use these two pieces of information to help me find the summation of k is going from 1 to n of 6 times a sub k. All right, now we said if we had a constant, which that 6 is a constant, I can pull that outside. So that's going to be the summation k goes from 1 to n of a sub k. All right. Up here at the top, it's telling me that the summation k goes from 1 to n of a sub k is equal to 2. So I can replace this whole thing here with a 2. So this just really becomes 6 times 2, which is 12. All right, the second one, we've got a difference, so I'm going to split it apart into two separate summations. This would be the summation k is going from 1 to n of a sub k, and then it's going to be minus 2, because I got a constant there, I'm going to pull that out. The summation a is going from 1 to n of b sub k. Now again, we have values. We were given values for the summation of a sub k and the summation of b sub k, so I'm going to substitute those in. This is going to become a 2. This is going to be negative 2 times negative 3, which gives me 2 plus 6, or 8. Oops, sorry about that. Okay, the one on the bottom, we're going from 1 to 15 of 2k minus 3. So again, I'm going to pull this apart into two separate ones. So it's going to be the summation k is going from 1 to 15 of 2k minus the summation k is going from 1 to 15 of just 3. Okay, this one I can pull the 2 out front, and I'm going to have the summation k is going from 1 to 15 of k, and this one becomes minus. Remember, since it would be 15 threes, I can just do 15 times 3. All right. This next part is where this formula is going to come back into play. So we had the formula on the other page here. Where did it go? Right here, for the sum of the first n integers, which was n times n plus 1 plus 2. I'm sorry, divided by 2. So I'm going to use that to substitute in to find the sum of the first 15 terms of this one. So it's going to become 2 times, n in this case is 15, so I have 15 times 15 plus 1, and I'm going to divide that by 2, and then it's minus 45 from that other term. Oh, sorry, I'm writing underneath that thing. All right, the 2's will cancel. So this ends up being 15 times 16 minus 45. 15 times 16 is 240. So I have 240 minus 45, which ends up being 195. Okay, I'm going to pause this video and then we'll continue with the next problem.